comes to that. I can't concentrate on too many things. Now, who am I talking to in here? Who is this for? Allison?
Yeah.
Okay, Allison, we'll do our best to include you in the class. And if any of you...
Oh, no, she's not on the thing. She says it's being recorded for her.
Gotcha. Okay. All right. All right. So, all right. Wednesday's extra help is coming around. Finished or not, the corrected review will be collected tomorrow. And by corrected review, I don't mean the correct answers copied onto your paper. I mean, I want to see the corrections made. All right. Now, yesterday, okay, this is important. I am laying down definitions. It is very important that you understand the import of this. When the sign we define, first of all, we have to have in mind the angle in standard position and its terminal ray. If the terminal ray is not on the X or Y axes, we have to be given the coordinates. Otherwise, we can make up our own coordinates. So, the sign is by definition Y over R. R is always a distance, and it is always a positive number. X and Y, their signs depend upon the quadrant. The cosine, so when I'm drilling you today and I say definition, you would say X over R. And you would give me the X coordinate along with its sign over the R. You can call it the hypotenuse if you want, but you won't always see a hypotenuse if the ray is on the y-axis. And then the tangent is the y-coordinate over the x-coordinate. Now let's just pause here for prayers. In the name of the Father, and of the Son, and of the Holy Spirit, amen. We said yesterday that our job is to radiate God the Father through our actions. Sounds simple, but that's it. Not yesterday, not tomorrow, right now in this classroom. And then through the hall when you get to your next classroom is just do what is pleasing in God's eyes. And you don't need a halo around your head. Your goodness will be perceived by your classmates, and you will be doing your little teeny part in the plan of God to lead you, your family, and your friends to God. In the name of the Father, and of the Son, and of the Holy Spirit, amen. So now, I have a question for you. In what two quadrants is the tangent positive? Write down that question. In what two quadrants is the tangent positive? The easiest way to answer that question until you are really, really good at it is to say, in the first quadrant, X and Y are both positive, which means that the sine and cosine and the tangent are positive, because the tangent is Y over X and they're both positive. So we would say in the first quadrant. Now, let's go to the second quadrant, where we go to the left and then up. In that case, which function is negative, the sine or the cosine? Which of those two functions, Natalie, is negative? Natalie? Don't be bashful about it. The cosine, because you are looking at the x value. The cosine is negative. The sine is positive. Then the tangent would have to be the positive sign, the positive x, y over the negative y. Now, the positive y over the negative x. So in the second quadrant, the tangent would be negative. Let's go to the third, where you have to go to the left and then down. The sine function in the third quadrant, is it positive or negative, Colin?
Negative.
Negative, because it is the y over the r. The cosine would also be negative because it is the x over the r. Now the tangent then would be a negative divided by a negative. Oh, in the third quadrant, the tangent would be a positive number. And then in the fourth quadrant, we go to the right, so we say, oh, the cosine would be positive, and then we have to go down, the sine would be negative. So the tangent would be the y coordinate, which is negative, over the x coordinate, which is positive, and we get negative. All right, so I shouldn't say equals 0, it's less than 0. All right, so we're thinking, when is the tangent positive? When both sine and cosine have the same sign. All right, it is not difficult, but you've got to memorize it. It's, if you know this and you can apply it, it follows. Now, we started this problem yesterday, so just go to your notes and ask questions as I go through this, and then when we get to the part that we didn't do, then you continue with us. We want the sine of 90 degrees. Well, in standard form, the terminal ray is on the y-axis. You need not be given a point. You can make it up. None to the right, up 1. You could have said none to the right, up 5. It doesn't matter. If you say none to the right, up 1, all right, the sign by definition, you're going to say x over r, y over r. What do you, give me the definition, Grace. The sign is?
Y over R.
Now, if I'm using 1, then r would be 1 because the distance up to that point is 1, and I would get 1. If I'm using 0, 5, y would be 5, but then the distance up to that point would be 5, and I would still get 1. Okay? Now, the cosine. All right, what is the definition, Anna?
X over R.
Correct. So we take the x coordinate, in either case it would be 0, divided by 1 or 5, doesn't matter, and we get 0. The tangent, give me the definition, Ariana?
Y over X.
Correct. Now we take our y coordinate and we put it over 0. If we had used y, we would be using 5 over 0. Either way, it does not exist. Okay? Now, a straight angle. Now, pi is half of the circle. Question?
So does the cosine not exist either if it's above 0?
Who said, doesn't 0, isn't that a number? If you use up all your money, you have 0 left.
So why does the tangent not exist?
Pardon? Cosine is x over r. The x coordinate is 0 and r is 1. 0 divided by any number that isn't 0 is 0. So the cosine of 90 degrees is 0.
And there's no tangent for it?
Pardon?
So there's no tangent for it then?
It doesn't exist. That's right. And shortly, next week, we will be developing these graphs. Okay, tangent function at 90 degrees, it shoots off to infinity. It doesn't exist. the tangent of 0 is 1, and we're going to, but at 90, it doesn't exist, period. All right? Now, and why? Because you're not allowed to divide by 0. All right, the sine of pi radians, which is 180 degrees. All right, the terminal ray is on the negative part of the x-axis. You need not be given a point. You make it up, but you just make sure it's on the terminal ray. So I have to go to the left. I'm going to make it easy. I'm going to go to the left 1. Now, I'm not allowed to go up or down. I have to use a y value of 0. And I want the sign. Give me the definition, Maria.
Y over R.
Can't hear you.
Y over R.
Correct. Now, the y coordinate is 0. Now, no matter, as long as I don't put 0 in the denominator, I'm going to get 0. But I want to point here, the r is still a 1. It's not a negative 1. The r is the distance from the origin to this point. How far are you from me? You're not negative 1 units from me. You're 1 giant step from me. All right? Okay, so now the cosine, pi radians is 180 degrees. Give me the definition, Tina.
X over R.
Correct. Fill it in. The x value is
Negative 1.
over,
1.
which is
Negative 1.
the tangent of a straight angle is, give me the definition. Logan,
Y over X.
y over x. So we take our y coordinate and divide it by negative 1 in column. What do we get?
0.
0, because you're allowed to divide by negative 1. Okay, now we want the sine of 3/2 pi. How many degrees is that? Well, I gave you, okay, a half of pi would have to be 90 degrees. Well, triple that. 3/2 of pi then would have to be, what's 3 times 9? 27. So it would be 270 degrees. You follow that? All right. You should not have to make a big deal out of finding that angle. You should be able to do it mentally. All right. So we have to put the angle in standard position. Lo and behold, its terminal ray is the negative part of the y-axis. So I go and I label a point. I don't have to be given a point. Just make sure you are on the y-axis, so let x be 0, and the negative part. Negative 1, you can make it negative 1 billion if you want. All right, now the sign, give me the definition. Ryan Stewart, what over what?
Y over R.
Y over R, plug it in. What values?
So negative 1 over 1.
Negative 1 over 1. And you are correct in saying, even though you're going down, that distance is 1. So the y coordinate is a distance of 1 unit. Okay? And therefore we get negative 1. Now the sign of negative pi over 2. Well, if pi is 180, then pi divided by 2 would have to be 90. Oh, we're looking for the sign of that negative 90 degree angle. Well, that is coterminal with your 270. So you can piggyback on that. The definition, Giovanna, is?
X over R.
I don't think so.
Oh, I thought we were doing just Y over R.
Well, and then now you got to be careful here. Y over R, plug it in. What over what?
Negative Y over 1.
negative 1 over 1, and you get negative 1. Those angles are coterminal, and their trig functions are all the same. That's why we talked about angles that are coterminal. Now, the cosine of negative pi, all right, in standard position, that is a negative straight angle. Well, we already have the terminal ray listed, so definition, okay, Justin Chassis, the what over the what?
X over R.
X over R. Continue.
Negative 1 over 1.
Very good. And you get negative 1. And that is exactly the same as the cosine of pi. They are coterminal. All right. Now, let's do this one together. You draw your own picture. This is what you would be given. Write that down. Theta in standard position, its terminal ray is in the 4th quadrant. You are given that the sine of theta is negative 5/13. Now let's draw the picture. So you go to the 4th quadrant. And, okay, you're thinking here, like over here, the sign, that negative has to go with the 5. It cannot go with the 13. 13 is the hypotenuse, so here, 13. So this is the angle. It's a huge angle. And the terminal ray, well, we need both coordinates, x and y. Which of the two coordinates do we have already? Dan Wang? When we were given that the sign is negative 5/13, we were given which of the two coordinates? Dan?
We were given
What is the definition of the sign?
opposite over
No. What coordinate over what coordinate? We just spent 10 minutes drilling that.
Y over R.
Okay, so we were given the y coordinate. We have to find the x coordinate ourselves. But we know that R is 13, and literally in this case, it is a hypotenuse. So, using the Pythagorean theorem, x squared plus 25, what's 13 squared? 100 and what? Yeah,
69.
can you say that again?
169.
Correct. All right, subtract 25 from 169, and you get 144. You will be doing this so much, you should not have to use your calculator. All right, the square root of 144, there are two. What is the square root of 144, Anna?
Positive
Positive and
and negative 12.
negative 12. But which one should I take for the x value? I know what quadrant I am in,
The positive.
the positive. All right, now I can answer the question. Definition, the cosine of that theta. Abigail, give me the definition.
X over R.
X over R. Provided you put that down correctly, now just fill it in.
12 over 13.
And you are done. The tangent definition. Ellie,
Y over X,
y over x. Fill it in.
negative 5 over 12.
And in the final analysis, I don't really care where you write the negative. The fact is, the tangent is a negative number. Good? Okay. Now, let's go to page 2. That's all right, you keep checking. Page 272, example 6A. 272. So you see here, we are working on, section 7.3. So actually, I mean, I could say that's due tomorrow because we're practically finished it. But here's the question. Name each quadrant described. Page 272, number 6A says the sine is negative and the cosine is positive. So in your mind's eye, you should draw your axes. And it shouldn't take you 10 minutes to draw your axes. So you're saying, in what two quadrants is the sine positive? Well, you're saying, well, first of all, what is the definition of the sine? Lori?
Y over R.
So in what two quadrants is the sine negative? Name two quadrants where y is negative.
3 and 4.
3 and 4, down here. 3 and 4. But now there's another restriction. Cosine positive. What is the definition, Lori, of the cosine? What over what?
X over R.
Now, because the x value determines positive or negative, in what two quadrants is the cosine positive?
1 and 4.
The cosine is positive when we go to the right, in 1 and 4. So the answer to this then is in the fourth quadrant. Do you follow? Would you like me to do that problem again? Thumbs up, yes, or thumbs down, no, I've got it. Do it again. So we begin by drawing the axes. Here's the reasoning. The sine is y over r. The sine is negative when y is negative. That's when I go down. So that would put me into the third or the fourth quadrant. And if that's all they said, then just say it would be either the third or fourth quadrant. I can't. But now, if the cosine is positive, go to the definition. X over R. Well, where is X positive? When you go to the right. The answer then is the fourth quadrant. Follow? And there's no other way to do it except mentally and quickly. You have to go through that reasoning process. Now, 8A. It says, without using a calculator or a table, solve each equation for all possible thetas in radians. Well, let's do it in degrees first. All right. Now, as soon as you see the cosine is 1, remember, the cosine is, what's the definition of the cosine? Definition, it is what over what, Colin?
X over R.
X over R. That's where you begin. And you say, well, if R, okay, if the cosine's going to be 1, then it's going to have to be 1 over 1. Do you see? So that means, let's see. Could it be a 0-degree angle, or could it be a 90-degree angle? It's going to be one of the two. If it were a 0-degree angle, then I would say X is 1 and Y is 0. So I would have 1 over 1, so it could be 0 degrees. Could it be 90 degrees? Well, if that were the case, then the cosine, it would be 0 1. Now, the x value then would be 0 over 1, and the cosine would be 0. Question?
Would it be 180?
Can't hear you.
Would it be 180 degrees?
Well, let's tackle 1, all right? Let's find out. Okay, so do you see that we have ruled out 90 degrees? Okay, now we could say, well, maybe it could be 180 degrees, in which case it would be -1 and 0. Well, let's see. Keeping in mind that cosine is the x coordinate, in that case it would be -1 over the distance, which is always positive. Rules out 180 degrees, because if it were, the cosine would be -1. You got it? Now, so we've cleared that up. 0 and only 0, and all angles coterminal with it. So we would say 0 radians and all angles coterminal with it. Well, 0 radians plus 2 pi radians plus 0 plus 4 pi radians. In other words, this is what we're looking at. 0 degrees, and then a whole revolution, 2 pi. Or go around 2 pi to 4 pi. Do you get the idea? So your answer then would be written as let me see, 2 pi k, where k is a positive integer. That's the element of the set of positive integers. So here I would go, all right, there's 0, then I would go 1 revolution, 2 revolutions, 3 revolutions, and so forth. So this is the proper way of saying it, okay? Now let's go to B. As soon as you see that the sign is -1, you are thinking that is, what's the definition of the sign, Ariana?
Y over R.
Correct. So, you're thinking, in order to get -1, well, remember, R is always positive. So it's going to have to be the Y value that is negative. So I begin with a picture. It looks like it's going to be that quadrantal angle, 270. You follow? Question?
Where did you get the 270 from?
You gotta open your mouth. I'm not gonna get 5 minutes to get you to open your mouth.
Where's the 270 from?
Where is what coming from?
The 270?
90, 180, 270.
How did you find? Is it because the Y is a negative one, so it stops at the negative one?
Yeah. Because Y has to be a -1. So X is 0, Y is the -1. And that takes me either positive 270 or negative 90. Either one of them. Positive 270 or negative 90. If I am using radian measure, this would be negative pi over 2. Pi being 180. If I'm using positive, then this would be 3/2 pi. Pi over 2 is 90, and I'm going to triple it. Okay? And then all angles coterminal with them. And if you're not good enough at writing it in terms of k pi, then just say it in words. Say it in words. And all angles coterminal with them. Okay? Now, as a matter of fact, we could say this plus all angles coterminal with it, plus 2 pi times k. Go around once more, then twice more, 3k. Now, where k is an integer, it doesn't have to be positive, because we could go, let me see, where k is an integer, plus 2n. Yeah, okay, that's good enough. Okay, C, the cosine is 0. Now, as soon as you're seeing 0, you know it's got to be 0, 90, 180, or 270. Now, the cosine is what over what? Justin Chen, what over what? Can't hear you.
Y over X.
No, it isn't. It's x over r. Well, you got to start with the right thing. Otherwise, you'll never get there. Okay, in order to get 0, the numerator has to be 0. And the denominator, you can always make 1. So if x has to be 0, then it's got to be on an axis where x is 0. So it might be positive 90 or 270. Okay, now, so let's see. Let's say theta could be 90 degrees. Let's say pi over 2. Now, watch this. It could also be negative. It could be 90 or it could be 270. Well, let's say plus pi. Don't go a whole rotation, just go a half of a rotation plus k pi. 1 pi from 90, if I add 1 pi, that's going to give me my 3/2 pi. If I take 90 plus 2 pi, that's going to bring me back to all angles coterminal with that. Okay? And then 3 pi, 4. So, because there are 2 answers, then don't go a whole rotation. Go pi, a half of a rotation, and you can pick up all of them. But again, you can say it in words. If your words say it properly, you can get credit. Okay? So the essence here is that you see it, and then we'll worry about your finesse in expressing it. Are we good? All right. Now, D. Now, the cosine is -3. Something should be bothering the heck out of you. The cosine is -3. Well, by definition, the cosine is, Giovanna?
Y over X, or X over R.
All right, you got to get that straight. Okay, which means that this is on one of the quadrants. Well, X is negative, say over here. But no cosine is bigger than -1 in absolute value. Because what do? We say, even if I use -3 here and 0, fine. The cosine would be -3 over now 3. And I get -1. You can't go to -2 or -3. If you go to -3, then just remember that your distance to -3 is 3. So you always get the -1. Does not exist. And if you go to the calculator and ask for the cosine of -3, go to it. All right, go to the calculator and hit second function cosine. Second function cosine. So I'm not looking for the cosine of -3. I am saying what angle has a cosine of -3. So second function cosine, type in -3, press enter, and what does it tell you?
Error.
Error message. Hit the road. Hit the road. It doesn't exist. No angle has a cosine of -3. Okay. Now, 10A. All they want, without using a calculator or a table, state whether each expression is positive, negative, or 0. 3 pi. Quickly draw a sketch. Now remember, pi is 180 degrees. So I'm going to go 1 pi, 2 pi, 3 pi. So I'm right back. It's 1 pi, 2 pi, 3 pi. I went 1 pi, another pi, and another pi. So I am coterminal with a 180 degree angle. All right, give me a point on that terminal ray. Straight angle. The y coordinate has to be 0. How about we use -1 for the, you can't use +1 because it won't be on the negative part of the x-axis. So the cosine, now give me the definition, Samantha.
Cosine is x over r.
X over r. The x coordinate is 0, and the x coordinate is -1, and r is, Samantha?
1.
1, +1, because it's a distance, so we get -1. So, in fact, we gave the answer. All they wanted to know, is it positive or negative? We gave them more than they asked. It happens to be a negative number, and for your information, -1. Now, the sine of 2/3 pi. Quickly, what is 2/3 of 180? Now, you should not need your calculator for that. 18 divided by 3 is 6. So 180 divided by 3 is 60. 2 times 60, we're looking for the sine of 120 degrees. If you use your calculator, you're going to fall way behind because you're not training yourself to use your brain. Now, draw a picture. 120 degrees in standard position would be in the second quadrant. It's more than 90, but it is less than 180. Is the answer positive or negative? Then you say to yourself, to go to the second quadrant, I have to go to the left and then up. The definition of the sine, Brian Issel, is
Y over R.
y over r. So it would be a positive number. Your answer is a positive number. The sine of 11/6 pi. Change it 2 degrees. 11/6 times 180. 18 divided by 6 is 3. So 180 divided by 6 is 30. 11 times 30 is 330. So get yourself, all you have to do is get yourself in the correct quadrant. Well, 90, 180, 270, 360. Where is the terminal ray of a 330 degree angle? If it's in standard position, where is it?
In the fourth quadrant.
Fourth quadrant. So we're down here. Then all you have to say is, to get to the fourth quadrant, I go to the right, and then I go down. Now the sine is what over what, Colin?
Y over R.
Good. Okay, so the y value, is negative. They're not asking you. In a later lesson, they'll say, well, what is the sine of that angle? That's tomorrow's lesson. All right? Cosine of negative pi is 180, so this would be a negative 90 degrees. There it is. We want the cosine of negative 90 degrees. It's right there on the quadrant. Okay. Give me a point. I don't care what point it is, as long as it is on the negative part of the y-axis. All right, Grace? First coordinate. Don't go to the right. Don't go to the left. So what do I put?
0, -1.
Yeah. You can go down negative 10 billion if you want. All right. Definition of the cosine. What is it? Grace? What over what?
X over R.
X over R. Well, the X value is 0. So that's your answer. It is 0. Now, they're just saying, is it positive, negative, or 0? Okay, number 18. Now, they give you a ray passing through -3, -1, which is in the third quadrant. And they want the sine, the cosine, and the tangent. You begin by saying, well, what is the sine? Definition. What is the sine? Justin Chassis.
Y over R.
Y over R. So you already have part of your answer. All you have to do is now use the Pythagorean theorem to find R. And the rest is very straightforward. So tomorrow we're going to go to the next level, which means that you really have to drill, and just take some heart. I have a hard time memorizing. So at the beginning of the year, I had to memorize all your names, and you guys expected me to